So question 12, for the given functions f and g completes parts a through h, for parts a through d, also find the domain. So f of x equals 6x plus 1, and g of x equals 4x minus 9. What they want us to do is find this f plus g of x. What that essentially means is simply f of x plus g of x. It just means add the two functions together. So f of x would be the 6x plus 1, and we're adding to the g of x, which is the function 4x minus 9. So we're just adding those two functions together. Since we're adding, these parentheses can just be dropped. So really all we're dealing with is this 6x plus 1 plus then this 4x minus 9. And we do have like terms, 6x plus 4x would be 10x. And then 1 and a negative 9 would be a negative 8. So f plus g of x is going to equal this 10 minus 6, 10x minus 8. So again, what it's asking for is the domain as well. So domain, notice there's no domain restrictions because as we talked about, 0, the variable would have to be in the denominator. Well, x is not in the denominator of a fraction, so there's no division by 0 error. And the only other thing we have issues with is you cannot take the square root of a negative number. Well, that means the square root symbol has to be present. So we either have to see x in the denominator or we have to see x inside a radical. Neither one of those situations are present. So there is no domain restriction. The domain is going to be any real number. So it's going to be this choice here. Let's see here, make myself a little bit of room here. So the next one says find f minus g of x. So notice how we would actually be doing f of x and we would be subtracting g of x. So in our problem, f of x is 6x plus 1. And we're going to be subtracting the 4x minus 9, which is the g of x. Now remember, in subtraction, the first parentheses are not necessary, but remember, when you're subtracting a whole expression, the easiest way to do it is just change the signs of what's inside the parentheses and add. So this becomes, instead of a 4x, this becomes a negative 4x. Instead of this being a negative 9, this is going to become a positive 9. And we're going to be adding that to 6x plus 1. So we're going to see then that 6x and negative 4x is going to give me a positive 2x. And 1 plus 9 is going to be 10. So f minus g of x is going to be the new function 2x plus 10. But notice how, again, if we talk about domain, x is not in the denominator of a fraction, and x is not inside a square root symbol. So if neither one of these is present, our domain is going to be, again, there's not going to be any domain restrictions. It's going to be this here. It's going to be, the domain is going to be any real number. That's going to be our choice. Let's see here. So next time we have f dot g, which means f of x times g of x. So this means to actually go f of x times g of x. So f of x was the 6x plus 1. And we're multiplying it by g of x, which is just 4x minus 9. So now we're going to push them together. If you push the two parentheses together, that's going to be multiplication. So the easiest way to do this is distributive property, or we sometimes call it FOIL. You're going to multiply the 6 to the first term, and then the 6x and the negative 9 become the outer terms to start with. So 6x times 4x becomes 24 and x squared, because x times x is, there's 2 present, so we have to use an exponent there. And then 6x times negative 9 is going to be, well, 6 times negative 9, I believe that's negative 54. So that's going to be a minus 54x. And then we have to bring the 1 through. We have to multiply the 1, that's the inner terms, and then the 1 to the -9 is the last terms, if you're using FOIL as a memorization tool. So 1 times 4x is going to be 4x. We could just continue on here since that's not much to do. And 1 times -9 is going to be a -9. We do have some like terms to deal with. Notice that the -54 and the 4 are like terms. So -54 plus 4. So if you are down 54 and then you add 54 to that, I'm only down 50 now. So we have then 24x squared minus 50x minus 9 is our new function. So that's going to be f times g of x. So again, to identify the domain, x is not in the denominator of a fraction. I don't see that. X has got to be beside the square root symbol. I don't see that either. So that means every number I pick for x should be able to go through this formula and assign a y value to that. So there's not any domain restrictions. So the domain, again, is going to be the set of any real number. So next one is we have f divided by g of x. So this means you have, let me make a little more room again. So f of x is going to be on the top, and g of x is going to be the denominator. So I can't remember what f of x was. So f of x was the 6x plus 1, and g of x was 4x minus 9. So we have 6x plus 1 on the top, and I can't remember, 6x plus 1 and 4x minus 9. So that's going to be my function. Now remember, this is a rational expression. Rational expressions, we have to factor and cancel out like factors. But since the denominator, neither term has a common factor, and this is already linear, remember only quadratics can be factored. So since this is linear, we have to leave that as is. So, but notice how there is a domain restriction because of this 4x minus 9. So the domain exclusion, what we're going to exclude is we're going to set 4x minus 9 equal to 0, and we're going to solve for x. So 4x would equal 9, because you just move the -9 over and make it a positive 9. And then if I divide both sides by 4, the 4 moves underneath, and that just becomes 9 over 4. Now 9 over 4, I don't think that reduces. So if I type in 9 divided by 4, that's going to give me a decimal. So if I go back to math and fraction 9/4. So since they want separate notation, we want an inequality here. So remember, the inequality symbols are the less than equal to, the greater than equal to, and then the does not equal to symbol. So the one they wanted us to use is this not equal to. So the domain is going to get, and we're going to write an inequality. So we have to have x involved here. X cannot equal the 9/4. That's what we're going to be excluding. So what this means is, this first x means all real numbers. This vertical bar represents such that, and this is what we're excluding. We cannot equal 9/4. So that what this means is every number but 9/4. So E says evaluate f plus g of 3. We've already got the new function f plus g. F plus g was this 10x minus 8 function. So to do this problem, what we have is f plus g of x was equal to this 10x minus, what was that again? 10x minus 8. 10x minus 8. F plus g of x was 10x minus 8. So if I want to evaluate f plus g of 3, 3's got to go in place of x, so 10 times 3 minus 8. So the 3 becomes our input value. It goes to the calculations of multiplying by 10, which is 30, and 30 minus 8 would give me then 22. So that means that f plus g of 3 would equal then this 22. F minus g of 4, well, we have to find the function f minus g of x to start with. That's 2x plus 10. That's that function here that we had, 2x plus 10. So we're now going to apply it down here. So we have f minus g of x was this 2x plus 10. Double check myself. By the time I get down here, I already forgot. 2x plus 10. It doesn't hurt to double check things. That's where most of my mistakes occur. So from here, we have to go then f minus g of 2. I'm sorry, of 4. That's where my mistakes happen. So 4 goes in. So it means we're going to have 2, and the 4 goes in place of x, and we do our calculations. 2 times 4 is 8. 8 plus 10 is 18. So 18 would be our result. So 4 is the domain value. It goes in, and the result is the 18, and that's what they're looking for. So our next function is this f times g of 2. Move this one down a little bit. So we need this function here. So we have 24x squared minus 50x minus 9. So we have this 24x squared minus 50x minus 9. See how well my memory was in 5 seconds. 24x squared minus 50x minus 9. Hey, not bad. So that's what f times g of x is. So f times g of x is going to be this function. And what they want us to do is evaluate f times g of 2, which means 2 goes in place of x. And I'm going to use parentheses for multiplication. 24 in parentheses 2 squared minus 10, 50 in parentheses 2 minus 9. And just let the calculator worry about the calculations. 24 in parentheses 2 squared. That's actually what, 4 times 24 would it be, like 96? And then I'm going to subtract 50 times 2. Well, 50 times 2 is 100. 96 take away 100 would be what, -4? And then if we subtract 9 from that, so if I'm down 4 and lose 9 more, that should be a -13. So we have a -13. So that would be our value there. So f divided by g of 1. So our function here was 6x plus 1 over 4x minus 9. So 6x plus 1 over 4x minus 9. Now remember, the only domain value we can't use was the 9/4. Or was it 4/9? Yeah, it was 9/4. So since the domain value is not 9/4, we can continue on with this problem. So f divided by g of x is going to be that function. And what they want to do is go f divided by g of 1. So all we got to do is substitute 1 into this function. 6 times 1 plus 1 over 4 times 1 minus 9. Well, 6 times 1 is 6 plus 1 is 7. 4 times 1 is 4. 4 take away 9 would be -5. So again, if I want to double check that, 4 take away 9 is -5. So usually we don't keep the negative on the bottom. So we either put it out in front or on the top. I usually like just keep it on top. So -7/5 would be the result there. And I believe my lab would probably want a fraction. They don't want decimals too often. But if they just say type something in, then you can use either form there. And I believe this is not a crazy decimal. So if I type in -7 divided by 5, that should give me some type of round or not rounded, but an exact value. So negative 1.4 would be the decimal value for that. All right, so that concludes that question there on operations involving functions. That was question 12.